So everybody agree cotangent is just 1 over tangent. Okay. Now, there's no reason to change the tangent, because if these both say tangent, can't I simplify them? Yeah. Good. So minus secant x equals sine of x minus 1. So for my people who were not on Zoom yesterday or who were not in class, can somebody explain why we are messing with the left-hand side? Why we're trying to condense the left hand? Can somebody explain that?
There's more, what is it?
You said it too.
Yeah.
Keep going, Kevin.
There's like more like trig functions on that side.
Yeah, there's more trig functions. There's more to play with, more to simplify, more to condense down. It's always easier to start with the bigger side and try to make it smaller than starting with the small side and trying to expand it. Okay? So is everybody good with this first step? Some of y'all got 85s on your homework because you did not do what I told you to do. What are you supposed to do each step if you're trying to prove something to someone? Explain it. Yeah, justify. So Oswald, what did we do right here? What did I use? Good, reciprocal ID. So Chris, we talked about yesterday, and I actually didn't say this, but I'll say it now because my mini-me is here. It's you. I love to argue because I can always back up my arguments. Right. Exactly. That's what we're doing here. I'm backing up my arguments. Okay. Now, lovely people at home, some of y'all changing these to sines and cosines, and then bless your heart, you don't know how to simplify. That's okay. Yeah. Why? I'm not quite sure why we're changing it, because Delta Math told y'all to. Delta Math doesn't do pre-cal as efficiently as Miss Poole does. The guy who made Delta Math was an Algebra 1 and Algebra 2 teacher. He does not teach pre-cal. So that's why we can't find a lot of pre-cal stuff up there. If I didn't tell you yesterday, try to get sines and cosines, it's because I didn't want you to. You don't need to do that here. Y'all made it harder on yourselves. This is just tangent squared over tangent minus secant, and we're trying to make sure it equals sine of x minus 1. Now, what did you do in this step?
I guess you would just have 1 and x.
So you multiplied or you simplified. That's what you would say.
Yeah.
Tell me what you did. Each step, justify what you did. Yes, because you are proving. If somebody was not in pre-calculus, let's say you were trying to prove this to a 12-year-old. They don't know that 1 over this times this equals this. You're justifying every single step. Isn't what this, not if you don't put the explanation. So a lot of y'all's parents, great example here. Somebody always asks me this. I'm not mad at you. Y'all are just trying to take the shortcut because you don't like to explain what you're doing. If y'all's parents looked at your homework and said, what the heck is going on? You should be able to just point at these and they should then be able to figure it out. So pretend like you're explaining it to someone who has no idea what's going on. You're going to justify every single step. Okay, so the question was, is it really necessary on your final exam? There are always at least 2 of these questions. And what they'll do is they'll put like a proof up and they'll show the work, and the question will be like, which of the following is the missing step? Or which of the following is the missing justification? So you do need to know what you would do at each step and each justification for it. Does that make sense? Okay. All right, what can we do now? Simplify. What is this?
Tangent of your x.
Good. Tangent of x minus secant x equals, and then the other side. I'm running out of room, so I'm not going to copy the other side.
So is sine x minus 1 its own little like function, or is it 1?
That is what we're trying to prove that the left side equals. So if I want to prove that you are 20 feet away from me, I can't get up and move and you also move. You can't move both things in a proof. You have to pick a side, prove that that side will equal the other one. Okay? It's not an equation that you're trying to solve. We're trying to prove the left equals the right. That's what an identity is. All right. I've got people asking, this breaks my heart, why tangent squared x over tangent of x is just tan x. What is x squared divided by x?
X.
Tangent squared x literally just means the tangent of x squared. There's 2 tan x's. Okay, so we're okay here. Justification, you can write simplify, you can write combine, I don't care, just make sure you write down what you did. I had kids last year on the pre-cal exam miss a proof question because it said which of the following is missing, and the answer was just simplify. And they chose something crazy because they didn't like actually look at the proof, I'm guessing. Or they had no idea what was going on, I'm not sure. All right, from here, we're trying to get on the other side. I am going to copy it down. We're trying to get sine of x. So you need to try to rewrite these, if you can, with a sine of x. We should definitely be able to do that part. Tangent is just sine over what? There we go. Now, can we rewrite secant to have a sine or cosine? Because we want to try to combine them. Okay, what can we write it as? Good. A lot of you got here.
Yeah, I skipped all of that.
That's okay. Is it kind of making sense though? It's not really anything new or hard. Good.
I just skipped everything you were
Okay. So let me ask y'all a question, because a lot of y'all got here and then you said sine of x minus 1 equals sine of x minus 1. What'd y'all do with the cosine? They don't cancel. If you have 1/2, let's say, if you have 3/2 minus 1/2, 1/2, Lord, 1/2, that's 2 over 2. The denominator does not cancel. It doesn't go away. It would be sine of x minus 1 over cosine x. That would be what the left side would equal. And you can't do anything from that point. It's just sine of x minus 1 over cosine. So are we going to be able to make the left equal the right? No, which is why I didn't say prove the identity. I didn't even tell you it was an identity. And some of y'all were freaking out. If the right side said sine of x minus 1 over cosine, then would it work? Yes. But it doesn't. The exam, I'm sure, will probably say prove the identity, but just in case they gave you one that didn't work, just make sure you read the directions, all right? Okay, people at home, any questions on this? People in class, any questions?
What did we do to go from like what was our proof between the last 2 steps?
So from here to here,
Yeah.
quotient identity and reciprocal identity. Because tangent is sine over cosine, that's a quotient. That's what you divide to get tangent. And secant is just the reciprocal of cosine. It's my natural color. I'm a natural blonde.
Lucky.
Yes. I thank the Lord for it every day. I already forgot what page we're on. The ADHD medicine is not working yet. Good grief. All right, 37. We're just doing more trig identities. I have 5. I would like to do maybe like 3 of them, and you guys try a couple if that's cool with y'all, and then I'm going to let you go do your classwork, okay? But first, I do want us to write down some tricks for these. Tips/tricks. All right. You guys already know the first one. Which side do we always want to try to start with? It's not always the left. The one with more stuff, the more complicated side that we could condense, right? Okay, so that's your first trick. Try to start with the more complicated / larger side, if that makes sense. The side that has more that we can try to condense. Do y'all want me to write down that we're going to try to condense it, or y'all are okay? We're okay? Okay.
Yeah.
Thank you, Prodnia, for noticing my hair. All right. The second trick is what you asked me this morning. If you see sines and cosines anywhere in it, then we're going to try to rewrite the other terms as sines and cosines, okay? So if there are any sines slash cosines, rewrite each trig function using just sine and cosine, if you can. It's not always possible. These are just tricks, so they do not work for everything. They're just things that you can try. Only got 2 more. If you see reciprocals, so somebody give me an example. Secant and cosine, sure. If you see reciprocals like secant and cosine, or cotangent and tangent, or cosecant and secant. Try to combine those to cancel out first. I think the first few examples y'all could probably do without me if y'all want to try them without me. Up to y'all. All right, and then the last one. If you have any squared functions, you need to keep in mind that it could end up being an identity, let's say a Pythagorean identity, to be more specific. Because remember, every single one of your Pythagorean identities is squared. That doesn't mean try to write it as a Pythagorean identity at the very beginning. Because sometimes you'll get what we had like in the warm-up where it was tangent squared over tangent. That'll go ahead and simplify. But these are just some tips and tricks that may help you along the way. All right, this is the most important one for life, for anything. I'm getting inspirational on y'all today. Keep the goal in mind. Keep in mind whatever you're trying to make it look like. How can I make it look like that right side? If the right side has a sign, let's try rewriting with sines and cosines. If the right side just equals 1, we're probably going to use an identity, a Pythagorean identity, okay? Keep your goal in mind. And Kelly, girl, you missed my sports talk, but Kelly, what makes perfect?
What makes perfect?
Yeah, girl, what makes perfect? In sports and life and anything.
Okay.
Practice, bitch.
Practice. Oh, practice.
These take practice. Don't get upset because you don't get it quite yet on the second day. I told you we're doing at least 3 days of these. So keep practicing, keep trying, keep the goal in mind. Sound good? Yes, no, yes, great. All right, let's do it. I really feel like y'all can do the first one. Y'all want to try the first one without me? I feel like y'all can do it. Let's do it. Everybody's going to try this one. And these are your directions. All of these will work. We're going to prove the identity. And I'm writing this just for my Ann. Did you see what I wrote? Justify. She's like, dag on.
Is it 2 with the
Yep, 2 sine squared x. You guys try this one. I'm going to pause my recording. So I want people later to try it too. All right. No, I didn't say you don't use Pythagorean identity. I said the answer is not just one Pythagorean identity. That's what she asked me. See, y'all all up in the Kool-Aid not knowing the flavor. $0.00 to mind your own business. Okay. I think Brody might be onto something because he's kind of looking at me and pointing. So everybody look. Which side has more that we can simplify? It is the left. You can't simplify the 1 and you can't really simplify the 2. You could write this out twice, but whatever, okay? The left side. What do you guys notice about the right side? What is the only trig function on the right? Sine squared. So can we write cosine squared as a sine squared? Because look, if we could write this as a sine squared, then wouldn't there be 2 of them? Can we write cosine squared x as a sine squared? Yes. Okay, what is it then? It'd be really nice if y'all would look back in your notes that I spent so much time making for y'all yesterday.
Use the Pythagorean identity.
Good. So I heard use the Pythagorean identity, and Anne's so smart, she already got it back there. That girl said 1 minus sine squared. Yes, ma'am, Anne. Cosine squared can be written as 1 minus sine squared. So my justification would be Pythagorean identity. Now, can I simplify? Yeah, what is sine squared, negative sine squared x minus sine squared x? Negative 2 sine squared x. Don't they equal? No, we're not moving anything. They equal, you're done. No, we're not trying to solve. You're trying to make the left match the right. It matches, we're done. You're getting ahead of me.
I'm lost.
Why are you lost?
At 1 minus sine squared x.
Cosine squared x, one of your Pythagorean identities in the picture of the notes that you took, says that it equals 1 minus sine squared x. So I just rewrote it as this. Because on the right side, I saw there are only signs. Look at your tips. If any squared functions, keep in mind you could end up using a Pythagorean identity. Let me change this word to using before y'all just think the answer is going to be 1 for all of them. I saw 2 squareds. I was like, probably need a Pythagorean identity because cosine and sine go together in a Pythagorean identity, right? Then if you look at the right, there was only a sine. So I was like, okay, can I rewrite the cosine as something sine squared? The Pythagorean identity for cosine squared x says it equals 1 minus sine squared x. I've never asked you to memorize anything. I told you you need to memorize the 3 main Pythagorean identities and be able to move them around. Yes. The right side? You can change the right side to the left side. That's just harder. Not everybody's brain works that way, but I can show you. So if you wanted to change the right side to match the left side, this green marker does not erase. 1 minus 2 sine squared x, you could say that that just means I have 2 sine squared x's, right? So 1 minus sine squared x minus sine squared x. It just requires thinking backwards and expanding. No, you can't move it. We're not moving. We're not solving equations. This is where y'all always mess up because you see the equal sign and y'all start to try to move stuff. You are trying to make the left equal the right. You are not moving anything. If I'm trying to prove Chris is 20 feet from me, I can't move and him move. You're not moving things. You take one side as it is, make it look like the other side. We're not solving equations, we're proving. I need to figure out who some of y'all had for math too, because they were supposed to do proofs with y'all. Your teacher was out because her baby came early. That's not her fault.
No word.
Stop, Chris. We know. I think she actually made y'all do proofs though. All right. I feel like we should be okay with example 1. That was supposed to be the easiest one, so I'm a little bit worried about some of y'all. Some of y'all look at stuff and you're like, yeah, I don't know what to do. I'm just going to wait for her to do it. That is going to screw you on the test. Woo. Let's see. Let's do this one.
What if they don't?
They will equal because that directions say prove the identity. So they'll equal. Good question.
Okay.
I always just like to throw in 1 towards the beginning. Excuse me. That doesn't equal, just to see if what y'all will try to do with it, really. See how we're thinking.
Is that cosecant?
That is cosecant. All right, children. Let's just make some observations first. I feel like that's going to help some of us, especially if we're virtual right now, because these are challenging. What side do we want to start with? Okay, the left. I agree. What do you guys notice on the left side?
It's all
Okay,
secant.
they said they're all secants. They're all squared. They're not all secants. I don't like that y'all said that. This is secant squared minus 1.
Yeah, that's what I was gonna say. There's
Ooh.
-1 in the denominator.
Good. Hold on, I got extra credits in class. These boogers are thinking. Natalie, I'm so proud of you. Natalie said secant squared minus 1 is, okay, I'm gonna write that down. Secant squared x over tangent squared x. This is a Pythagorean identity. So again, the trick eyes wrote down, I'm moving my notebook for a second. If anything's squared, you could be using a Pythagorean identity. Off the bat, we can rewrite that. Good job, Nat. So proud of you. Okay, I'm going to ask you why you want to do that. I'm not saying you're wrong. Why do you want to change the top to 1 over cosine? Okay, hang on. That was so cute. I like it though. Drake said, "Oh, I'm going to change the bottom." Drake, what you going to change the bottom to?
Secant over cosine. No.
Sine over cosine. Okay, good. So stop. Look at what you have. This is a good learning experience. We'll go back and do the explanations in a minute. Cosecant, everybody should know that is 1 over sine.
Yeah.
So Drake said, okay, if I can rewrite it with a sine somewhere, I could probably make something cancel out. So he said, I want to rewrite tangent as sine over cosine. That's a good move. You don't have to do it that way. There's a second way to do this one, but that's the way I did it. So everybody watch. I'm going to do the bottom as sine squared over cosine squared. I know it's small. I'm running out of room. So Chris, on the bottom, it says sine squared over cosine squared. So now look at what you have in the bottom. Can I rewrite the top? Can I rewrite secant squared to have a sine or a cosine? Which one? Good. 1 over cosine. I like that. Good job, children.
And then you have to multiply by the reciprocal.
Yeah. Yes. So look, I have one fraction divided by another fraction. We do not know how to divide fractions. So what would you do instead, Kendall, one more time?
Multiply by the reciprocal of the denominator.
Good. So cosine squared over sine squared. All right, kiddos, what happens with the cosine squareds?
Cancel.
Excited. Did you figure it out? I'm so proud of you. Good. 1 over sine squared, which is just cosecant squared. So they do equal. I just proved that. Hopefully yours is a lot neater than mine. I'm sorry I ran out of room. She took my markers. All right, let's write down our explanations. Make sure we're all on the same page. Very first thing we did at this step was what? Oh God, I'm irritated. That's not gonna go in.
Pythagorean ID.
Lit. I need to quit teaching and go join the WNBA. Pythagorean identity, good. They don't make jack squat, by the way. Also wasn't that good. All right, good. Now what did we do right here? From here to here. Reciprocal and quotient. Good job, Oswald. My boy said I got this. Reciprocal and, I can't spell, quotient identities. I will make it neater on the other pages, y'all. I'm so sorry. Then this third step right here, we just multiplied, right? You can
Yeah.
say multiply by reciprocal. You can even say divide fractions. Anything. You can say simplify. That's fine with me. And then the last step, we knew 1 over sine squared was cosecant squared because of what?
Reciprocal property.
Identity. Good. All right. So you guys were okay with number 2. Y'all are weird. Number 2 was way harder than number 1.
That one was fun.
Okay, good. That one was fun. Oh, Natalie, quit trying to make your notes so neat. All right. People at home, questions on number 2. I'm just going to keep doing more so we can get it kind of practicing in a groove. All right. I do think I want y'all to try number 3. I can help you get it started if you want, but it's similar to number 1. Have I used any thetas yet? Let's throw a theta in there, because why not? No, it doesn't matter, but again, like I said on your exam, if the question gives you thetas and you type in an X in the computer, I would think that it would count it wrong. They don't give partial credit on the final exam. I'm going to help you think through it for a second. It's similar to number 1. Which side looks more complicated? The left. So let's see if we can condense and simplify the left. Now, what do you guys notice we have on the right? Only cosines. So can we rewrite this sine squared as a cosine?
Yes, ma'am.
You can do it, figure it out. I'm gonna pause my recording. Chris, just watch, okay? All right. All right. Multiple ways to do it. I think the 2 ways I'm gonna show you are the easiest. The way I did it was I replaced sine squared theta with 1 minus cosine squared. That is your Pythagorean identity.
I just didn't know if you 3.
Okay, that's okay. That's your Pythagorean identity. Sine squared is 1 minus cosine squared. Stick the 3 out front. Okay.
I think they're
I'm gonna bring the other stuff down. Plus 4 cosine squared theta. So this was Pythagorean identity. From here, what can you do with the 3 now? Distribute. So that would be 3 minus 3 cosine squared theta plus 4 cosine squared theta. So you can write that you distributed, you can write that you simplified, you can write that you multiplied. All of those would be acceptable for your justification. If I'm going too fast, somebody let me know. So now from here, can we simplify?
Yes, ma'am.
So -3 plus 4 is just
1.
+1. So it's just 3 plus 1 cosine squared theta. Isn't that what I was trying to get on the other side? Okay. 3 plus cosine squared theta. That's the first way you could do it. That's the way I did it. Anytime you want to rewrite something or replace something, you can just put it in parentheses. I'm not quite sure why that was throwing y'all off so much. Think about in math 1 when you did substitution. If y equaled something, you just went and plugged it in for the y in parentheses, right? Yes? Okay. Y'all are very smart kids, but y'all got lots of gaps in your math 1 and math 2.
You can put it on the outside.
There's a 3 right here.
Yeah.
I'm not rewriting 3 sine squared. Does your Pythagorean identity have a 3 in it? No. So we're not messing with the 3. Bring the 3 down. Sine squared theta in your Pythagorean identity, it says it equals 1 minus cosine squared. So I'm just putting that in instead of sine because all I see over here are cosines. Now, I like the way Eric and Ann did it too, so I'm going to show you a second way for this one. And then I'm going to let people ask questions. Y'all, I'm really not trying to be ugly at all. Don't take this the wrong way. Don't get your feelings hurt and get all up in your feels. That's one that I wanted to do today. And then after y'all struggled on the warm-up, I exited out because I don't think we're there yet. But this is a pre-cal one. We cannot just look at something and say, yeah, I don't get it. I'm going to ask the teacher. Y'all got to try to think. Use your noggins. You're doing great. I'm proud of you. Okay. Eric, you want to talk me through what you did? Yes, you do. You got it. Let's go. Extra credit. Okay. Okay. He said, I know that sine squared plus cosine squared equals 1. Continue. Okay. Keep going. I'm gonna stop you I'm stopping you now. You'll keep going in a second. He said 3 was the smallest number, but he knew he had 3 sine squareds and 3 cosine squareds, and that just equals 3 because sine squared plus cosine squared is 1. He said, okay, there's 3 of them. Now what did you do? What's left on the end right here? What'd you just say? There's a 4th cosine squared theta that he just brought down. Super good. I like it. Less steps. If you don't understand that way, do you have to do that way? There's even a 3rd way to do this one that I know of, but it's longer than these 2, so I'm not showing you. There's multiple ways to do all of these. You don't understand what he did, don't do it. Do the first way. My heart is troubled that some of us struggled so much on the first one. That means you need to be in office hours this afternoon. Okay? I'll do one more, I think. Oh, do I do a complicated one? I don't know which one to do.
Miss Poole.
Hang on one second, babe. I'm having an inner battle with myself to figure out which one to do.
I was going to ask if we could try a complicated one just to see if we could do it.
I would love that. I'm going to have some people start whining, but yes, that works for me. I may just say you're not allowed to ask me questions. You can ask questions out loud. I'm not coming and looking at your paper. Okay? Connie, why do you look scared? Why do you look scared? Okay. All right. Yes, Kendall. Great. Sounds fantastic. Let's do. I just don't know which one I want. I can't make a decision. Let's do this one. All right. I'm good. All right. Let's do this one. And Kendall, this one really isn't that complicated. There was a harder one I was going to do, but I just don't trust it yet. So we're going to do this one. But it is more steps than the other ones we've done. All right, you guys are trying this one. I'm going to give you 3 minutes and then I'm going over it. You are allowed to ask me like verbal questions out loud, but you're not allowed to say, can you come check mine? No.
Okay, wait. It took me a while, but I got there.
This was my first step. If you didn't do this first, but then you ended up getting this, that's okay. But you are allowed to do more than one thing in a step. You just have to justify everything you did. Does
I think
everybody,
I got it.
does everybody see how I rewrite secant as 1 over cosine? So that is a reciprocal identity. Then I rewrote tangent as sine over cosine. What is that right there? A quotient identity because you're dividing. Good. And then that's all I did. I just put the multiplication sign because those two things are technically multiplying, right? Nope, you can't touch both sides. Quit trying to mess with both sides. That's not a proof. All right, from here, we should have been able to simplify 1 over cosine x. Some of y'all subtracted first. PEMDAS babies, you got to multiply first. What is sine times sine?
Sine squared.
Over cosine. So all I did in that second step was simplify, correct? All right, third step. When we're subtracting fractions, if they have the same denominator, can I just put everything together?
Yes, ma'am.
So 1 minus sine squared x over cosine x, good. So that's also just simplifying. So I'm gonna draw a little arrow. That's what we
And
do.
then it's just the Pythagorean identity.
Good. 1 minus sine squared is just cosine squared x. That is a Pythagorean identity. Some of y'all need to make flashcards for your Pythagorean identities. Or start writing them with like mirror markers all over your house. Put it on the bathroom mirror. Put it on the downstairs bathroom mirror. I don't care. But start putting them places. Put it in your car. Sticky notes where you'll start looking at them every day and know them. And what's cosine squared divided by cosine?
Cosine.
Cosine, we get that just by simplifying, and then we know cosine is just 1 over.
Secant.
Very good. And that last one, we just simplified in the middle. This last one is a reciprocal identity. Do we feel like we can do a couple of these for homework? It was supposed to be classwork, but y'all had a lot of questions. That's good. So I am going to change your homework. Give me 1 second. I need to look at which ones I don't want you doing. We can do that. I want us to try that. I think we can do it. Stop backing up. I want you to do, I lied. I want you to do all the ones that I had. It's only 5. 4, 5, and 8 are only 2 to 3 steps. So they're super easy. 2 and 3 are a little bit challenging, but I do want you to try them, okay? But they're not more steps than this. I'm showing you mine real quick.